And now we're ready to do our chamfering around the top edge of this part. Chamfering is going to be this edge right here going all the way around. We did draw it in Inventor to be about an 1/8 inch or 100 thou, I think, somewhere in there. And it was 45 degrees, so it'd be 100 thou over, 100 thou down, essentially, is something like that we were planning. So we're going to go top view, and we're going to go tool path. We're going to contour. It's going to be a little bit different to get this set up. We're going to cheat a little bit, but it'll get us the end result. Contour, we're going to grab that top edge just like we did for when we did the contouring around the outside. So we're going to grab the bottom to get that whole surface again, and OK. In the tooling window, we want to go grab the 3/4 inch chamfer mill. So select 3/8 inch chamfer mill. Filter, none, and this one right here when we hover says chamfer mill. So we're going to grab that and OK. And it gives us all the chamfer mill options, and there actually is not a 3/8, so we're going to have to change some settings in the tooling window when we get there, but we'll select 1/2 inch for now. And OK. Said OK on the error that came up. Alright, so we're going to change the tool diameter to be 3/8 or 0.375, and we're just going to change the label to be 3/8 as well. So it now should be a 3/8 chamfer mill for the purposes of what we're doing. This is going to be in tool slot 4 in the mill. So all 3 of those are getting changed. Alright, for RPM of this particular tool, if we come back so here's the bit, 3/8 inch chamfer mill. So cutting speed of 400 times 4 divided by 0.375. Gives us 4 grand. We can double that to 8 grand. However, our mill caps out at 6,000 RPM. So we're going to go ahead and cap this out at 6,000. All right, for our feed rate, RPM 6,000 times, essentially there's 2 working cutting teeth on here, times the chip load. So 6,000 times 2. We'll go a medium, 0.005, gives us a chip load of 60, or a feed rate of 60. Plunge, we're not plunging into the part, so we can keep that number, and we're already rapid retracting. So when we click out and go back in, we'll see that we now have a 3/8 inch chamfer mill in tool 4 with those settings. Holder we're not doing anything with, so we'll go right to cut parameters. In cut parameters, again, we're going to change some stuff up here. We're going to, instead of computer compensation, we're going to turn it off. So it'll run center line of the bit on center line of our cut path. And then, because we don't want the tip of the bit to do the work, we're actually going to step it off the wall by 100 thou, 0.1. So wall is 0.1 off the wall. All right, so then we're going to go into depth cuts. We're going to turn them on. And we're going to go ahead and do a 0.1 max with a finishing pass. Finishing pass is always 8 thou. And we'll go ahead and do keep tool down just to save some time in tool change type stuff. All right, we're going to leave lead in, lead out. We're going to leave break through. We're actually going to turn off multipass. Don't need it. Don't need tabs. So in linking parameters, all absolute, which it's already set up to, which is nice. And here I need to talk a little bit. So we've got our part. So here's the edge of the part if we're looking at it from the side. And here's our cutting tool. And we want to get it to put a chamfer essentially on the part. So what we did was we moved it over 0.1, so it's like right here. And then we need to bring it down so that this wall is essentially hitting right here, is what we need to do. So we need to move it down a specific distance to do that. Well, if I move it down 0.1 down, it's going to be right there. It's not actually touching the part because it's a 45-degree angle. So if I go over and down 0.1, it's just like if that tip of the part was right on the corner. So I actually have to move it down farther than 0.1. So I'm going to move it down 0.15, which is going to give me a 0.05 chamfer, essentially. So I need to move it down 0.15. But I need to go deeper than that because technically I'm going 0.15 from the top of the part. Right? If I do depth and I choose top of part, it's 0.2. So 0.15 deeper than that would be negative 0.35. Top of stock, I'm going to go ahead and choose the top of the part again. Negative 0.2, and everything else here should be just fine. So we did a depth of negative 0.35. We did depth cuts of 0.1 and 1/8 thou for finish. This is the page we made some changes. Compensation type to off, and stock to leave on walls 0.1. And let's go look at the pretty simulation. And here comes the chamfer. Took 3 passes and gave us a nice clean chamfer around the edge. Let's go ahead and look at front view. Alt S, green, green, back plot. Here comes our dimples, and here is our chamfering. Right there, it's making a cut, and here should be a finishing pass. Not quite going to the original drawn chamfer, and that's okay. It's just giving us a nice clean edge. And that is almost done. Our next video is going to be drawing some lines onto the Mastercam part, and then contouring those lines with a 1/4 inch ball end mill to make it look like we have our line paths.